Hello, hi, good morning, everybody, and welcome all of you in our short uh, webinar related to this data science introduction. My name is Dr. Sudipta Samanta, and right now I am involved in different kind of data science project related to healthcare, the agriculture sector, uh, then some business related data. Today I'm going to discuss about the basic about data science. What are the tools we needed? What are the whole data cycle about data science? And lastly, I'm going to show you a small demo so that like at the end of this short session, we have at least an idea like what the whole data science means so that we can start from the beginning and do the different courses so that we will master in this particular field. So now data science is the most revolutionary technology of the era. The main reason for that is every day because of this internet, cloud computing, social media, every day we are creating huge amount of data. And currently, every person on the earth created nearly 1.8 megabytes of data on an average per second. And this data basically comes from chatting, searching, image, video uploading in different social media like YouTube, Facebook, etc. And since we produce this huge or enormous amount of data, so definitely we need to find a method that can analyze and interpret the data. So basically, whole data science is to extract information from this huge amount of data. And today, the agenda is first, I'm going to discuss about very briefly about what is data science, then the data science life cycle, and try to understand the different components within that data science life cycle. And after that, I will discuss about the different skills for data science, different skill set required for the data science. For example, the uh, at least basic statistics knowledge, the machine learning, deep learning, and why this deep learning is extremely important for the data science. And then I'll show you a couple of real world example, the huge job opportunities related to data science. And finally, I'm going to show you a simple demo with a diabetic data set. So now, what is data science? So data science is, there are lots and lots of uh, like version of what is data science, but the simplest is extraction of useful insight or knowledge from the data in order to solve the real world complex problem. So basically, when you have a data, somehow you need to find out the important information to give you the answer of the problem. That's the data science. And it is a continuation of the fields of data mining, means searching data, try to explore the data, and the predictive analysis means build a model which can uh, predict the outcome when your model is ready. So next, this is the whole data science life cycle. The data science life cycle has seven important components. First one is the business requirement. You need to ask a question, interesting question, you need to solve. Then based on that particular question or that business requirement, you need to collect the data. It's not like any data, so you need to collect the data which can solve the problem. The third one is, in most of the time, the raw data is like, it's a very messy one. So there are lots of null values, missing values, outlier, different problems. So the third step is basically the data processing. So that is the most important and time consuming steps. And after that, when your data is ready for analysis, then you need to explore the data. Means basic statistics, different kind of plotting. Just try to fill the data. How different components of the data or different parameters, whether it's important or not. So just digging, play with the data. That is data exploration. And after that, that is the feature selection. So when you explore the data, then you need to select the important features or important inputs or important variables which can give you the answer of your problem. So that is the feature selection. And finally, when you have all those important features which can explain or maybe solve the problem, then we need to build the predictive model. And when your model is ready, finally we are going to deploy the model for testing purpose. So these are the 7 most important components for the whole data science life cycle. Now I am going to give you a brief explanation or understanding for each of the points. So first one is the business requirement. Business requirement is basically try to understand the problem, and based on different fields, different problems. For example, it may be some retail chain related data, and somehow the management observed that for the last quarter there is a sales drop for a particular something, and that a company wants to understand why that sales drop, what are the parameters, and they need to understand, so that like in the next quarter they can solve that problem, so that the business is as usual or maybe increase little bit trend. So basically, and that is like for retail chain related business. Now for example, like healthcare related data, for example, like in case of Singapore, one of the biggest problem related to cancer in Singapore, it's called nasopharyngeal cancer. It's like nose, throat, this portion related cancer, and that is one of the big problem in Singapore. So, and for that particular cancer, if somehow doctors can predict at very early stage, detect very early stage, then there is 100% chance of cure. So like for this kind of problem, we need to identify or detect the disease at very early stage, stage 1. So different fields, different problems, and we need to understand the problem first, and then identify the central object and identify the variables that need to be predicted. For example, for detection, it may be some image related detection. For business related, maybe some other kind of parameters. So different fields, different problems, different things we need to understand, and then we need to dig more. So that is the business requirement or ask a important question. So next is like based on the business requirement or based on your question, we need to collect the data. So and like what data do I need for that particular project, and then like what are the data resources. It may be like, for example, for healthcare related data. We know like, okay, if we have the images, then somehow we can manage to build something so that like we can detect. But the problem is like, who is going to give us the data? There are lots of available data sets, but like specifically for healthcare data, that availability of the data is not that easy. So for that, maybe you need to collaborate with the hospital, or you need to purchase from some big company, or maybe there are lots of sources. And but there are several public data sources are available. For example, like Kaggle dataset. uh, there are lots and lots of data freely available, and that is the best starting point for any data scientist. Like if you go and sign in the Kaggle, then you can search whatever is your field, you can find some data, and basically you can download the data, you can play with the data, and whatever you want to do. So basically that collection of the data and to know what are the data sources, that is the next step. And then like, how can I obtain the data? So if your data set is too big, then you need to like, it's not like straightforward download the data, then you need to follow a couple of steps to handle that big data. Okay, so these are the first two components. So and these are the for example, like few examples of the data. This one is like supermarket sales data set. Here it's a like beautiful tabular data. And these are the different parameters. For example, invoice ID, city, branch, gender, different things. So basically, supermarket company maybe give you this particular data set, and after that you need to solve their problem. It may be some image data set, you need to classify the data set. It may be some time series related data set. It may be like movie review data set. uh, it may be DNA, RNA, protein related data set. So different data set, different question, and different things you need to do. Okay, so these are the data set. And after that, when our project or question is ready, we manage to collect the data, then our next step is the data processing or data cleaning stuff. So basically transform the data into a desired format, so that like we can mm, 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 like do any kind of analysis. And this is the most time consuming process the whole in the data science life cycle. Now data cleaning is basically, in general, most of the real world data is so messy, and we need to clean up before we use. For example, maybe some bad format, wrong data, so some missing data, and so there are several things we can do. For example, like missing data. Say this data. So say you somehow you collect this kind of data, some country, year, and there are lots of nan values. So several ways we can handle this missing data or nan values, and we need to take a decision based on like how big is the data. For example, like say I have this kind of table, and there are, for example, 1 million data points are there entry. So now if we found like, okay, there are only 5% data points with missing values, then 5% with respect to 1 million data points is nothing. Then we can directly say, okay, let's throw the data, and no need to handle that part, because those numbers could be anything. So now that delete that particular column or particular row is the easiest solution if your data set is big. But for example, you have only 1,000 data points, and out of them 20% have all those missing value related problem. Then based on the data size, we basically replace those nan values. For example, like we calculate the mean or median or mode, different basic statistical parameters for that particular column. Here, for example, there are lots of nan values related to that HOMI side. So basically, there are 100 points. Out of them, 20 nan values are there, and the rest 80 have some number. For example, 3.4, 4.5, different number. So if we calculate the mean of whatever numbers available, and we can replace nan with that mean value, that is one of the sensible choice, or maybe some median. So different ways we can follow to replace that nan value if our data set is not that big. Somehow we need to restore the data, otherwise it's not possible to build the predictive model. So the missing data related problem one can solve in two approach. One is if your data is too big, don't worry, just throw or delete those data. Or if your data set is not that big, then you need to understand the or calculate or explore different basic statistics, and based on that you can replace those nan values. And next one is like useless variables. For example, like if you want to predict the salary of the some Singapore, within Singapore population, then maybe like definitely that educational qualification is one of the major variable which is obviously correlate. It may be age, it may be different things, but somehow like within that data set there is a like column where like what's your favorite color of your shirt, like what. So I don't think there is any kind of correlation exists between your preferred color with your job salary. So always there are few variables which are basically useless to answer the question. So every time we basically try to find out those useless variable and delete those variables. And another steps is like transform variables means string to integer. Again here, for example, the second data set, say for example passenger sex, it's either male or female. Now before that model building, we need to convert this male female into some number. And here, based on how many categories or how many different classes are there, we basically replace. For example, here it's like male and female, so it's only two classes. So maybe male is 1 or male is 0. Based on that, female is either 0 or 1. So we replace male to 0, female to 1, or vice versa. So, and finally, this is sometimes most important. So we need to normalize the important features. So that normalization means, say you have several columns of data, several variables. One column is maximum or range is maybe 0 to 10. Another column is like 0 to 10,000. So it's totally different kind of distribution. So for model building purpose, it's always good to normalize the data set. Means like we apply some conversion so that everything is in between 0 to 1. So it's called normalization. So these are the most important steps for data cleaning. Of course, there are a lot more, but these are the most important. Every time we need to do all those things. So the most important things are, again, try to handle the missing data. If your data set is too big, it's easy just to throw or delete those data. If it's like 5% or 10%, who cares? But if your data set is small, maybe 1,000 or 2,000, based on your problem, then you need to somehow manage to restore the data and replace those missing value with some sensible number. It's not like always mean or always median. It may be sometimes zero is the most sensible number, something. Second step is basically transform all those variables where like your string to integer, because computer cannot recognize your male or female. So based on how many categories are there, you need, we basically replace those into some number. Then that feature uh, rescaling or normalization, basically everything scale down in between 0 to 1. So these are the most important steps in data cleanup. So next one is the data exploration. So basically the previous steps are you collect the data, you clean the data, and now your data is ready. So now you need to explore the data so that like you have the feeling like, okay, these are the important parameters, these are not the important parameters. So all those things you need to explore. So data exploration is basically understand and get a feel for what is expected and what are unexpected. For example, some error, some data points may be outlier. So different things you need to understand. So the first step everybody basically follow during data exploration is try to think about the data, what domain it is, what background, the data collection method, because this data collection method is directly connected with the uh, error. So how much error, possible error in your data. And after that, like try to explore in terms of basic statistics, all those, it's mean, standard deviation, median, different basic statistics. And then try to understand the dependencies between different variables. So means it's like how different variables are correlate with each other, whether correlation exists or not. And after that, we basically plot the data, different plotting here, scatter plot, maybe some draw some line, try to understand whether it's increasing nature or decreasing nature, and also the frequency distribution of each of the variables. Okay, so these are the different kinds of graphs we every time during data exploration. So this one is the scattered plot, how your data looks like, some histogram, some pie chart, some normal line plot. So this exploration part gives you a feel about the data. So how basically everything connected, which one is important, which one not important, which one you need to keep, which one basically no need to keep within the data, so just throw. So all those things you slowly understand during this data exploration steps. After that, the feature selection. So say you have initially there are hundreds of columns and you explore the data and you somehow find like, no, this only 10 columns or 10 variables are the most important one. The rest are like all meaningless. So you basically delete all those things and select those important variables or features. So this feature selection is one of the most important steps during predictive model building. So feature selection is the method of finding most descriptive features which can describe your problem, which uh, so and always good features helps you to build a very simple but interpretable model. Okay, and best features may be a subset uh, uh, of your whole image data set, or it may be some combination, it may be some transformer, it could be anything. Okay, so this feature selection is the most important step, and for that you need to have a very good domain knowledge, and you have to understand the statistics of the different variables or different variables. Okay, so and how basically people select this feature? So basically domain experts can manually pick, so basically level, and with the help of this basic statistical analysis, a correlation, it may be like two parameters or two variables are highly correlated, so you can combine those two, or you just take one, so no need to take the both at a time. You can reduce the dimension of your data using some special technique like principal component analysis or linear discriminant analysis. So there are lots of techniques using which you can reduce the dimension. And finally, automatically select the features. That is basically the deep learning. And before deep learning, this feature selection is always a problem, because for example, like you want to build a model uh, uh, which can predict maybe some disease related prediction, but you are not a doctor, you don't know anything about the field, and there are lots and lots of medical images, or those kind of complicated images are there, where like without domain knowledge you cannot say anything. Even like the person who have huge domain knowledge like 30-35 years experience, their accuracy also less than 40%. But this deep learning, which is a special kind of machine learning, so using that deep learning, one can automatically select the features which are most descriptive in nature. So later I will explain a little bit more about deep learning, but these are the way one can select the features. Okay, and next and final steps are like let's predict the model, and when your model is ready, we basically deploy the model for testing and monitor the performance. At this point, when your data is ready and we are ready to build a model, in general, we build a machine learning based model. Okay, and there are several classes or classes of machine learning, but the two most famous one are supervised and unsupervised learning. There are reinforcement learning, semi-supervised, but these are the most two common learning. One is supervised, another is unsupervised. Now the supervised machine learning is basically when in your data the outputs are available or outcomes are available, so then it's a supervised learning. But if the outputs are not available, just it's a data, there is no connection with your actual question, it may be it connected, you don't know, there is no outcome in the data, then it's an unsupervised learning. So supervised learning is basically when your label or outcomes are available in your data, and if that is not available, then it's unsupervised learning. Now within supervised learning, there are two types of model we can build. One is the classification model, and that is the regression model. And in case of unsupervised learning, so it may be some cluster analysis to understand whether any kind of groups are present inside our data or not. We can reduce the dimension using some special technique like principal component analysis. So many more things we can do. But these are the most important two classes within machine learning: supervised, unsupervised. Within supervised, we can build two types of model. One is classification, another is regression. And within unsupervised, since the outcome or levels are not available, so in general, we basically analyze the data using some clustering, and we can reduce the dimension. And finally, if we found some cluster, then using those information, we can build some model. Say this is one of the data sets, a diabetic data set. Okay. And these are the different parameters available in that data set. The first one is pregnancies. This 6 means how many times that particular person basically pregnant. So 6 means 6 number of times. Glucose, blood pressure, skin thickness, insulin, BMI index, diabetes pedigree, function, age, and outcome. This outcome, 1 or 0, and this 1 basically means the person have diabetes, 0 means no diabetes. Okay, so now based on this data set, different questions one can ask. For example, I am interested to build a model which can predict the person has diabetic or not. Okay, so my question is, I want to predict the person has diabetes or not. So this outcome is basically my level. And how many numbers are possible? Either 1 or 0. So only 2 possibilities are there. So when there are specific number of possibilities categorically, here it's like only 0 or 1. It may be 10 different types of disease. And so in that case, outcome may be 0, 1, 2, 3, 4, up to 9. But the numbers are specific, like it may be 2, it may be 5, it may be 10. So this kind of data is called categorical data. So when our outcome or when our predictive column is like some categorical data, discrete values. So for this kind of question, we need to build a classification model. Again, like some other person is not at all interested about the prediction of diabetes. Maybe he is interested to predict BMI index. Now this BMI index, this number maybe could be anything. It may be 33.6, it may be 33.61, it may be 33.67, it may be 34 point something. So infinite number of possibilities are there in case of BMI index. So this kind of data is called continuous data. Okay. And if you want to predict something which is continuous in nature, then you need to build a regression model. So based on our question, what model we want to build, we need to check how many possible numbers are there. Whether it's continuous means infinite number of possibilities are there. If infinite number of possibilities are any number, then it's a regression model we need to build. If only specific like some fixed number of possibilities are there, here it's like 0, 1 means only 2. So then it's a classification. So that's how we basically decide what kind of machine learning based model we need to build, whether it's classification or regression. Now, there are steps, several steps we need to follow before this machine learning related predictive model building, and this feature selection and target. So basically based on your question, different target and different features. For example, this first one where like you want to uh, uh, predict the diabetes. So this is our target. All these parameters are basically our input. For second model, this is our target. And for second model, this outcome also an input. So based on our question, what kind of model we want to build, we basically select the features and target. And after that, we split the data set into three different data set. So basically, say you have your whole data set, somehow you collect the data set, and then you need to split the data set into three different components. The first one is called training, next one is validation, and second one is the testing data set. Now, the ratio of this split is basically depends on how big is your data. But the main point is like you have enough data points for testing. What does it mean? Say I have 1,000 data points in my data set. Now I decided to like, okay, let's put 60% of my data in a training data set and rest 40% data split 20-20 and put it in validation and testing data set. So if I put 20% in validation and testing data set, then if the whole size is 1,000, then 200 data points in the validation and 200 in the testing. So 200 data points is, I think it's enough to test whether my model predict or interpret correctly or not. But say my data set is like 100,000 data set. And if it's 100,000, and if I put again 20% in the validation, 20% in the testing, then it's a wastage of the data. So 20% means 20,000 data I put in the validation, 20,000 in the testing, and 60,000 in the training. So based on the data set, we need to decide like how many data we put in the training, how many in the validation, how many in the testing. But always keep in mind, more data sets in the training, more data in the training data set is always good to build the model. And it helps you to build a model which can predict unknown data. And so that splitting ratio, it could be anything. And slowly when you gain the experience, so you can decide your own. And after that, you need to select the model, build the model, train the model with respect to training data set, then evaluate the performance of the model with respect to validation data set, and then check whether your model is underfitting or overfitting. Now, this underfitting, overfitting concept is not that straightforward, but in simple terms, if your model predict correctly with respect to unknown data, then it's a good model. But say if your data predict nearly 100% with respect to training data, but your model is not that good to predict with respect to unknown data, then your model is an overfitting model. And if it opposite, like your somehow our model prediction is not that good with respect to training, but it's good with respect to unknown data, then it's an underfitting model. So those are the different things we need to check whether our model is overfitting or underfitting. And finally, we don't want our model neither overfitting nor underfitting. We want a good model. And when we achieve that, we basically save the model for future use or deploy the model uh, to testing its performance. So these are the steps for machine learning, and these are the different machine learning based models. I already told you, like within supervised learning, the two classes are classification and regression, and within unsupervised learning, uh, the clustering kind of model one can build. And there are different name of the models. For regression, it's maybe simple linear regression. For regression problem, for classification more kind of model building, different kind, so many different types of classification models are available. It may be KNN, means k nearest neighbor, support vector machine, decision trees, random forest. Obviously, neural networks also are there, and clustering PCA for unsupervised learning. So these are the 7 most important components in the data science life cycle. First one, again, just to so first one is the business requirement, means you need to ask an important question or whatever exciting question in that particular field you need to solve. Then based on that question, you need to collect the data. Third one is the process the data. You just check whether any missing values are there or not. You convert uh, your data, you basically normalize your data. So those things you need to do. And fourth step is explore the data using basic statistics, some graph plotting. And based on that, the fifth, the most important point components is basically the feature selection. And based on that feature selection, we basically build our model. If that feature selection is perfect, our model also perfect. If those features are garbage feature, then basically we build a model which garbage in, garbage out, nothing predictive. So this feature selection is the most and complicated steps in this data science life cycle. Each and every components are important, but somehow you can manage to understand and handle all those components. But this feature selection for specific domain, it's extremely difficult. Even for experts also cannot handle or select features efficiently most of the time, specifically for healthcare sector. At this point, deep learning comes. So deep learning is nothing but a special kind of machine learning model which is neural network based. And the main difference between machine learning and deep learning is, say you want to build a model based on the machine learning. So first one is you collect your data, means your input, and you do whatever you want to do to understand or explore the data. And after that, you basically select the most important descriptive features. So that feature extraction or feature selection is the key component for this model building. If your features are not good, whatever model you build, that is not good enough to predict with respect to unknown data. If you can extract most meaningful features, then a simple model can predict with respect to unknown data. So that is the machine learning, your input, feature extraction, model building, which give you the output. But in case of deep learning, which is the neural network based model, you just pass the raw inputs. For example, image. So you pass the image, your model, neural network based model, do something what till today nobody knows 100%. But this model basically extract the features and classify your data. So in case of machine learning, feature selection and model building means either classification or regression, whatever. So these two steps, in case of deep learning, only one step. So that's why today deep learning is the most important component in data science. The main difference is in deep learning can extract the most meaningful features from your data automatically. But previously, in any machine learning, they cannot extract the features automatically. You need to build your own feature or select your own features before that model building. So these are the this is the most important difference between machine learning and deep learning. So that's why today in all those exciting fields like computer vision and natural language processing, so deep learning is the solution, no other options. And these are the real world examples of machine learning or data science. For example, the spam mail detection, face recognition, Netflix movie recommendation. So basically, in all those real world application, background is the machine learning based model. Driveless car, Siri, then AI related application on healthcare, and specifically in Singapore, this particular area is extremely demanding. So every day, hundreds of new startup related to AI related application on healthcare is basically formed in Singapore. So it's a huge job opportunities in this particular domain, AI healthcare. And here basically how to detect the disease from different kind of images or some healthcare data. So these are the just recent application in healthcare sector. Identify tuberculosis, and even like just a couple of months before, there is a very nice report of identify lung cancer from chest x-ray data. So lots of things are going on. Robotic assisted surgery, detect Alzheimer disease, detect brain bleeding, so lot more. And also in security like parking spotter, face recognition, defect detection, road defect detection. In manufacturing, robot manufacturing, within manufacturing unit, automatically you can make the app which can detect the defects. So in any field, you can ask lots and lots of questions, and data science, machine learning, deep learning is the only solution. Okay, next is the required skills which are extremely important to become a data scientist. So that domain knowledge or database, of course, those are important, but these skills like programming language, today Python is the most popular one. Now, why most popular? Because there are thousands of freely available modules are available. Whatever is your field, whatever is your question, there is something freely available so that you can start from that. You no need to start from the scratch. So thousands of modules in any field. Like in case of agricultural, it may be some spectroscopy data, it may be healthcare data, it may be time series analysis, it may be stock exchange data, any data related. There are some module already available within Python so that you can explore. So that at least mastering one programming language is extremely important for data science. Next one is like basic statistics, like at least one should know the what's the meaning of mean, median, mode, distribution, skewness of the distribution, kurtosis. And so basically those things are important to decide like a specific data points, whether it's an outlier or it's an important data. If you don't know what outlier is, if you don't know the statistics, then you cannot ignore those ones. So always your data looks like a messy. So basically understand statistics is extremely important to explore or to make decisions. And finally, to build the model, machine learning and deep learning and understanding purpose. It's not like nowadays everything is available. So if you learn Python, within Python there are lots of free modules are there. For example, scikit-learn. Within scikit-learn, you can just call any model. So just one line of code and your model building is done. But until and unless you understand each and every details of each of all those different models, what the mathematical foundation, at what circumstances we pick specific, for example, like for classification kind of model, it may be KNN, it may be naive Bayes, it may be neural network, it may be lots of options are there. But how to pick the best one for your data, for that, and that is the most important decision one need to make. So that's why one need to understand each and every detail of the machine learning. And of course, deep learning is nothing but a part of machine learning. But within deep learning, whatever model, we need to build it based on neural networks. And there are mainly 3 or 4 different types of neural networks we need to understand clearly within deep learning. First one is that fully connected one, which is good for any kind of tabular data, gene data, or protein related data. Then it's convolution neural network, which is the best solution for any kind of image data set. Then for natural language processing is recurrent neural network, and also like generative adversarial network. So if we claim like, okay, we are the master in deep learning, so we need to understand and need to know the each and every details. Then only at the end of the day, we can build the model which can predict with high accuracy. So those are the required skill sets. And job related to data science, there are so many different names, but the 2 main are like data engineer and data scientist. So data engineer roles is basically based on the question, collect the data, process the data. And data scientist basically explore the data, feature engineering, or like select the features and build the predictive model. But these 2 is again, it's not the only two. There are other like data analytics, data research scientist, research engineer. So lots of job titles are there. But based on what kind of company uh, that job role is basically very. For example, like if it's a startup company, so data scientists basically need to do everything, starting from asking the question, or maybe the question is there, problem is there. So starting from data collection to model deployment, each and every point, everything that data scientists need to handle. But if it's a big company, then there are so many different employees. So there is basically the exploration, feature engineering, and model building. And uh, that is the role of data scientist, and data engineer basically collection and process. Okay, so this is the overall of the data science. So today I basically tried to give you an flavor or overview of the whole data science field, the different components, what are the skill sets, and so basically try to give you a path if you want to become a data scientist starting from the scratch. For example, you have no prior knowledge of programming, or you don't know statistics, you don't know anything. So like how you basically proceed step by step to become a data scientist. And at this point, I'm going to show you a simple demo, so that like at least like you have some feeling of how the different steps basically. Okay, so basically in the demo, I want to show you uh, how to handle a simple data set, which is diabetic data set, and how to build a model using that data set. So always, and this whole process is within Python language. So in case of Python, first like we need to uh, so basically this first step is we import different libraries, different things, packages, so that like we can handle that. So now next step is obviously the upload the data set. So within Python, there is a library called Python pandas, and using panda you can handle any kind of data set. It may be CSV format, it may be XLS format, all those different formats it's beautifully handled using pandas. And so df equals to pd.read csv. So this is my file, diabetes.csv. So using panda I basically read that file, and df.head, basically I want to check the first 5 lines. Instead of head you can put tail, so that like last 5 lines. Okay, so this is just to take a look how my data looks like. And after that, it's like length, and df means, df is basically this one. Whatever file I read, whatever data I read, I put it in the df. So length df means how many rows are there, how many data points. So there are 8 number of data points are there in my diabetes data. And this 9 means 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 columns means 9 different maybe features or some information. So 9 columns, 768 number of rows are there. Now this df.describe, so it gives you the overall basic statistics of your data. It's count, how many number of counts for each of these parameters, mean, standard deviation, minimum, 25%, 50%, 75% with respect to your mean value, maximum. So these are the basic statistics you can easily handle within Python just using this df.describe command. After that, since here I want to build a model to predict that diabetes means this outcome 1010, 1 means diabetes, 0 means normal. So then it's good to know how many diabetic patients are there, how many normal patients are there. So basically this DA and this outcome means that name of that particular column, outcome. If it's like instead of outcome, say it's a diabetic or not, so then we need to put that over here. And this dot value count gives you like how many datas for normal and how many datas for diabetic patient. So basically within this data set, there are 268 number of diabetic data patient data and 500 normal. Next, let's explore the data, means the different histograms for different parameters. And from this histogram, always it's important to take a look how this distribution looks like, whether it looks normal or not. For example, this glucose one, it almost looks like normal distribution, but all this diabetic pedigree function, so it's a like one-sided long tail. There are different meaning. I'm not going to discuss all those details, but just to take a look of the data, how it looks like, how the distribution. So that's how we basically explore the data. Then I check what are the name of this one and save it in that column.x. Maybe later you can use those. So next one is, let's check the whether it's missing value or non values are there or not. So using this comment. So here these pregnancies, there are 14.45% data points are there with null values, NaN or Na kind of. Glucose 0.65%, and there are insulin is the maximum, nearly 48% data points are missing. Okay, so and again here the total number of data points are only 768. So if we throw this nearly 49% data points, so it's a huge loss. So somehow we need to do something to replace those null values. So let's check the correlation, basically whether any extremely correlated parameters are there or not. This, all those diagonals one are basically the correlation with itself, like pregnancies, glucose. So these are not important, but these are the important thing. For example, like this looks like greenish, and this more greenish means very close to 1, means this one maybe 6, 0.6. So there is an indication like age correlate, somehow have a correlation with these pregnancies. Okay, so from correlation plot, lots of things one can interpret, and this information is important to select the features. Here, no significant correlation means like nearly 0.9% or very close to 1. So there are few numbers which are more than 0.5 but not that significant. Okay, next one is prepare the data set for training. Remember that when I discuss about machine learning, so always we split our data set into training and testing. So here also, so we load our data set 768 number. Now we split the data set into training and testing data set. And here this testing size 0.2 means 80% data points I want to put in my training bucket or training data and 20% in my testing. So if you don't, if you want to like, no, I want to like, for example, 70% data, I want to put it in the training data bucket and just change here. Like instead of 0.2, it's 0.3. So that's how you can easily handle this data splitting part. And this random state, no need to understand right now, but this one means you basically use some random seed so that uh, uh, every time similar sets of random numbers one can generate. So it's called random seed. It's, and here I split the data into 80-20, and initially the whole data set is 768 number of data points, and after splitting there are 614 in the training and 154 in the testing data. Next, after splitting, I basically handle those missing values with that simple imputer function, and that is already implemented within Python. And here I basically replace all those missing values with 0. Okay, and after this replacement of the missing values with 0, now if I check how many missing values are there, check, see, all are 0, means everything is clean in terms of missing value or null value. So at this point the whole data cleaning process is done, and I am going to build a classification model using logistic regression. And within this scikit-learn linear model, there are all possible machine learning based models are available. So only thing you need to import that classification model from this scikit-learn.linear model. And after that, I mentioned my model equals to logistic regression, and I want maximum iteration 1000. And I want to fit the model, means train the model with respect to training data set, and after that I want to predict the or check the performance of my model with respect to testing data set. And when I check and this accuracy, like how many unknown points inside the testing data, it predict correctly. So these are the function like accuracy score. So there are so many different functions are available within scikit-learn. So I found like it's this particular classification model, which is based on logistic regression, it can predict nearly 78% diabetic data correctly. So this is the simple demo of one classification model building with diabetic data. Now, okay, so here in that Aventis, we basically launch several programs related to this data science, and these are the upcoming series of lectures, of classes, online classes, because of this lockdown. So in 3rd May, so if you guys interested, just register. And finally, if you have any question related to different kind of training, these, that, please contact this Rina. Here is the email and contact. Okay, next. So I'm going to stop here.